Today we are last marking period we did writing verbal expressions. Now we're going to go into writing equations. So we're going to go back and forth between words to they're going to say it in word form, and we're going to write it out in algebraic form. Um, and then we're also going to be given algebraic form, and we're going to have to put it into words. So we're going to go ahead and get right to it. Writing equations. To write an equation, identify the unknown for. So I'm going to. The unknown for which. Identify the unknown for which you are looking and assign a variable to it. So we're going to assign a variable. Then write the sentence as an equation. Look for keywords such as is as much as, is the same as, or is identical. Those all indicate the equal sign. So consider the Daytona 500 example below. The length of each lap times the number of laps is the length of the race. So if we let L represent the number of laps, right, we're going to have the length of each lap. So 2.5. Each lap is 2.5 miles. So it's kind of 2.5 miles is one lap of the Daytona 500. So the length of each lap is 2.5 miles times the number of laps. We're going to say that is L. Makes sense. L for laps equals the length of the race. Well, we know that Daytona 500 is 500 miles. So it would equal 500. So we would have 2.5 times L equals 500. And that's what you would do. We took it from words into an algebraic equation. So let's do a couple examples together. So 7 times a number squared is 5 times the difference of K and M. So what I like to do is I like to circle the is. That is our equal sign right there. Equals, right? So now we have our left side and our right side. So let's look at our left side. We'll do that in green. 7 times a number squared. So that number is squared and it's 7 times. So I'm going to say 7x squared. That's 7 times x squared is the equal sign, which we already have, 5 times the difference of K and M. So the difference of K and M, that means that it is together. All right, so we have 5 times the difference. So that means K minus M has to be in parentheses. So that tells us that our answer is 7x squared equals 5 times the quantity K minus M. And that's that. So let's go ahead and do this one now. 15 times a number subtracted from 80. All that occurs before the is, which I'm going to circle. And then our right side is 25. So that means that we have our equal sign is here, and then on the right side is 25. So we're going to look at what are we doing over here. So 15 times a number, we know that that's 15n. We'll do n as our variable. You can choose whatever variable. Subtracted from 80. So it's subtracted from 80. So it's not 80 being subtracted from the 15n. It's the 15n being subtracted from 80. So that means that it's 80 minus 15n. So that tells us that our answer is this. 80 minus 15n equals 25. And I like to get into the habit of boxing off my answers. It's always good, especially in math where you have all the work on your paper many times. All right, so now we have this guy, this problem. Refer to the information at the left. In how many days will 261,000 flights have occurred in the United States? So in 1919, Britain and France offered a flight that carried 2 passengers at a time. Now there are more than 87,000 flights each day in the U.S. So the information given in the problem is that there are approximately 87,000 flights per day in the U.S. We are asked to find out how many days it will take for 261,000 flights to have occurred. So we're going to write an equation and let D represent the number of days. It makes sense. When we pick variables, we usually pick variables that make sense to the problem. So D for days. D for days. So what we have is it's 87,000 flights per day times the number of days, D, equals 261,000. That's a comma. So what do we do now? We're just going to solve it. So when we solve, I'm going to divide both sides by 87,000. And I get D equals 261,000 divided by 87,000 is 3. So it would take 3 days to have that many flights. And if I was to check, I would just do 87,000 times 3. And 87,000 times 3 is 261,000. So it checks. So let's do this example here now. There are 50 members in the North Carolina Senate. So there's 50 members. This is 70 fewer than are in the North Carolina House of Representatives. How many members are in the North Carolina House of Representatives? So, where did that go from? Okay, so there are 50 members in the North Carolina Senate. So I'm going to set up my equation. 50 equals, we know that this is 70 fewer than the number of House of Representatives. So if I say House of Representatives is the variable R, we know that R, the total number of House of Representatives, minus 70 is the 50 that are in the North Carolina Senate. So how many members are in the House of Representatives? Well, now I'm going to add 70 to both sides. So I didn't mean to do that. 70 plus, that's a 70, not a 20. 70 plus 50 equals 120 equals R. So the North Carolina House of Representatives have 120 members. That's our answer. All right, so we're going to do another example here. So this is translating the sentence into a formula. So the area of a triangle equals, that's our equal mark, the product, which is multiplication, of 1/2 the length of the base and the height. So area, will let area of the triangle be capital A, B is the base, H is the height. So area equals 1/2 base times height. And product means I'm just multiplying all three of them. So area of a triangle is 1/2 base times height. So we're going to go ahead and, yep. So this is our last one. Translate the sentence into a formula. In a right triangle, the square of the measure of the hypotenuse C is equal to the sum of the squares of the measures of the legs. So on our left side, we have the square of the hypotenuse C. So we're going to let the hypotenuse be C. And so C squared is equal to, and then we're going to do our right side, the sum of the squares of A and B. And I think you might already be picking up on this. So A squared plus B squared. And if anybody knows what that is, you've taken geometry. This is the Pythagorean theorem. Pythagorean theorem. And so that's all we're going to do for today's lesson. Again, and then this is your live instruction for the day. So we'll have another lesson for tomorrow queued up. Thanks.